Hi, my name is Diogo Guerreiro. I'm the VFX supervisor at CG Imagine, and today we're going to work on a shot that I'm creating for a TV series about some indigenous tribes in Brazil that lived for more than 5,000 years in a totally flooded area. And for today's shot, we're going to approach the close-up shot of these drastic tide changes. It's not a daily tide change, it's a seasonal thing that comes from a dry season with many months totally dry and some months are totally filled. And we're going to use Houdini and Redshift for this shot. The reference is this frame. There is a frame from a time lapse from National Geographic in the same area, and this time lapse just show that the water coming up and very a big difference in the water. So there's a lot of techniques that we're going to cover. I hope you enjoy it. Please subscribe. I'm going to keep posting these tutorials, and let's dive in. Okay, so let's start placing a height field node. Change the grid scale to something small if you want more resolution. Remember that you can always come back and change it later. And let's add a noise. Now add a draw curve, and let's use the XZ plane on it so we can project the line on the XZ plane. Now we need to resample it so we have more uniform points. In my case, I thought 20 in the length was a good number. The new sweep node in Houdini lets you select a round tube geometry, so you don't need to add a second input. So now we can play with the scale along the curve and give it a bit more interesting shape. We can always come back and change this later when we see how this applies to our terrain. Let's add a mask by object node and increase the blur a bit, so we have a mask that we can change anytime we want, just changing our curve input. You can use spheres, cubes, any type of geometry for masking your height field. Place your height field mask by object node before your height field noise. Invert the mask and don't forget to uncheck the center noise. Now we can play with the scale and amplitude of the noise until we find something that we like. Now we can go back to our sweep node and increase the width so we can make our river larger. Let's repeat this process and create another sweep, using the same curve. This time, let's make it thinner. Plug into another noise. This time, click in center noise and blur a bit the radius. Play with the settings. We have now a variation on our river bed. This is also a good way to create a beach. Repeat it one more time, but we use the first sweep node and invert the mask, so now we can affect the top flat part of our terrain. So let's blur the radius a bit so we can have a softer transition. And let's add another height field noise. You can also change the type of noise and keep playing with the amplitude and element size until you find something that you like. To give it more variation, place a distort node. We will do this in two stages. In the first one, we're going to use a very big element size, like 1500, so we affect the general shape. Now we can use a small element size to give more details to the surface. And let's play also with the amplitude until we find something that we're pleased with. Now let's use a mask clear node so we can just see the whole terrain without this red mark on top. Now place a road node, but remember that this is a time dependent node, so press play and see how it affects. Stop when you're happy with it. If you also have a problem with the viewport, create a new viewport and the problem is solved. Inside the road node, play with the colors in the gradient ramp if you want to better visualize your terrain. By default, our terrain is 1000 by 1000 meters. For us, we need a much smaller terrain. So let's use HF Xform to change the scale without losing the resolution. I want something like 50 by 50 meters, so 0.05 is the number to go. You see? The same resolution. The right scale in terrain can be tricky, so I'm using Tommy Geo just to have a more clear reference of it. So I decided to make it even smaller, like 0.04 or 40 by 40 meters. Let's create a grid and change the color just to visualize how our water plane is going to interact with our terrain. Yes, great. Now back inside the HF terrain, we are going to use a mask by feature node. And we can now create masks that will later be used to define different material areas for our terrain. For this first mask, I'm using mask by slope and using something that would select just the more vertical areas and the edge of our river. When you're happy with your mask, place a height field output node so we can export this map. I'm going to export a point EXR 4K map. We'll save the mask into the alpha channel and auto remap it from 0 to 1, so we know our map will be black to white. I created two more maps, one for the bottom layer and another one just to give a bit more variance to the bottom one. For those maps, I selected mask by height instead of slope and just select the very bottom of our terrain. So now let's create another geonode and let's add an object merge to it so we can bring our terrain in. So let's convert this terrain to real geometry using height field convert. Play with the density if you need more or less resolution to your terrain. Great, we don't need to worry with UVs. Height field terrain already gave us good flat UV. So I am using Quixel Megascans for my textures. I recommend it, but feel free to bring your own textures. I'm choosing 3 different textures for my terrain. I want like a clay texture, kind of a grass texture, and a mud one. So now I have all 3 textures inside my material tab, and I'm going to create a new RS material builder node, and I'm going to copy and paste each material inside it. In my case, I used 3 different ones. So now let's bring on the masks that we saved from our terrain with the height field output node. Before we start to render, let's add the sunlight or sky dome and adjust your render settings, and let's place a camera. I personally like to test each material individually so we can see more details like the scale and other parameters as well. Because my terrain already have a lot of details, I decided not to use a displacement node and instead only the normal map into a bump map node, and don't forget to change it from height field to tangent normal. Yeah, it's looking great. So let's start layering the materials. Use a material blender node. The order is important. Each layer number is on top of the other one. This is the opposite of Photoshop layers. The blend color input is where you should add your mask. Because it is in the alpha channel, use a color splitter node and drag the alpha output to the blend color input, like that. Repeat this process for all the layers. Yes, I'm really liking it. Not forget the power of Houdini procedural workflow. We could always go back to our draw curve and change the shape of our river, and all the mask would be adjusted automatically. I reused one of the materials in the bottom to create a better blend for the scene. Now let's add another geonode and bring your terrain in. This is for the scattering the vegetation. We will create different scatter nodes for different type of assets, like one for grass, one for bushes, and one for trees. This way we have more control over the placement. Now let's add some masks to select where you want to scatter the points. I'm using the mask by feature and selecting by height as an attribute. Create the scatter node and make the adjustments. Don't forget to uncheck keep bringing terrain and match slope, normal and direction. Give randomization to up, a small number, something like 3, 4, 5, and full 360 degrees to the yaw. Now it's time to bring our vegetation. I have a library of plants I created and saved as an RS proxy files. They are already fully textured and ready to go. I have this pack available for purchase and 3 free assets as well. The link is below. These assets are a lifesaver and save you so much time instead of adding plants and texturing as well. Even if you don't want to use my library pack, I recommend you create your own. Please subscribe and I will post another video step by step in how to create your library as well. For this I used a node called RS Instancer from Saul Espinosa. The link is below. It optimized a lot of how to bring your RS proxies into your scene. So let's add a line and then an attribute create node. Change the name to weight. This way we can control the proportion of one specific asset into the scene. Don't forget to change the type to primitive. The value will control the proportion in relation to the other attribute weight nodes. Repeat the process for as many assets that you are going to scatter in your scene. Even if you're not using the instancer node, just plug an object merge into your scene and use the same attribute create node. Merge all and plug it into the third input of your scatter node. For the instancer node, we have one additional step of diving into the scatter node and changing it from centroid to origin in the copy to points to node. Now add the instancer node and rename the tag attribute the same as your scatter node. Add the number of objects you have and drag them into each slot. In my case, it's 3. Change the number of each slot input to match a merge node. Now adjust the settings for the amount of instances. The outer radius contributes even more to the amount of scatter points than the coverage attribute. So for something small, use a tiny outer radius. I have a way of working with Houdini, and because it's procedural, my idea is that you should keep moving forward because you can always come back and make adjustments. So at this point I wasn't happy with my grass, but I kept moving and decided to deal with that later. Now let's repeat the process for scattering the bushes. Yes, cool. I like it. So now let's do the same thing for the trees. Okay, great. So now let's fix this scene and add more dimension to it, so it doesn't look so empty. Duplicate your terrain and the scatter geonodes. So for the background terrains, we don't need the same resolution, so we can reduce the density of the hide field convert node. You could also use a poly reduce node and would take more time to cook. So now let's use a null node as the parent for the background terrain and scatter, so we can translate them both at the same time. Make sure that your object merge is set to into specified object, otherwise it won't move. So let's duplicate it one more time. We have a problem. The tree in the background are not showing up. Let's fix this issue. Because our mask is procedural, we use the height to make a selection. But when I place the background terrain, I move it by 46 centimeters down in the y-axis. So I need to bring the same difference to my mask selection. That is better, but let's increase the size of the bushes and the amount of trees. Yeah, much better now. So now let's work in the water shader. Create an RS material builder, change the preset to water. Add subsurface mood scattering, so we can add more depth to the water. Play with the color and the settings until you are happy. In my case, I wanted this dense brownish look to it. For creating a more dense atmospheric look, I decided not to add any VDB, but instead change the volumetric scattering into our Redshift render node. Play with the settings until you are happy with the results. The main settings are scattering amount, attenuation, and the color of both fog and scattering. Great, we're almost there. Now let's take care of the water. Add a small ocean from the ocean shelf menu. Delete the internal volume. We won't need it. Change the settings in the ocean spectrum node. Increase resolution. 11 is great. Reduce the wind speed and the scale. Because it is a small area, we don't need to worry with masking patches to give variation to the scene. We need to export the maps to displace our ocean grid using Redshift. There are two ways. Let's start exporting the displacement maps. Go to the ocean preview node, check the UV attribute. Change the basic settings and let's save it to .exr format and keep it to 32 bits. Check bake all displacements to one layer and change the resolution. I chose 4K. Press save to disk and wait. Let's go for the second method. Dive inside the ocean preview node, right click and press allow editing of contents if locked. At the bottom right corner you find a copy network named Baked Maps. Double click on it. The second method is better used for small ripples on wakes, because it will export the cusp maps that will drive a bump map and not the displacement map. Inside the cop network, in the top right, you'll find a gen cusp single node. Plug the raw output to this node so we can export the cusp maps. Adjust the basic settings like resolution, where to save it, and the frame range. Click render and wait. Back to our ocean node, create a grid, a UV project, and initialize it to the best plane, and add a material node. In your material water shader, add a texture. Load your displacement map, if you want real displacement in your water. Plug it to the displacement input in the Redshift material. Don't forget to enable displacement in your object. Go into the Redshift Object tab and clicking on Enable Displacement. If you just want to use a bump map, as we described in our second method, load the cusp maps. Use a bump map node and plug the bump input. Now you can disable the displacement on your object. Let's try both. If you don't see a big difference, I suggest you just keep with the bump map because it will render much faster. Finally, let's animate our camera, and in my case I will also animate the water plane so I can show the different tides. Because it is a seasonal tide and not a daily one, I decided not to use a wet map so it doesn't give the impression of short period of time for the tides. If you want to learn how to create a wet map, please watch my free tutorial about that. The link is below. I really hope you liked this tutorial and you were able to add a few more weapons to your skill set. Don't forget to subscribe if you want to see more tutorials like that.